All right, welcome America. Welcome Selena Gomez in India to live studio recording in 202 with an introduction to Pythagorean theorem. All right, so today we are going to learn the beginnings of what's called the Pythagorean theorem. It's a very useful theorem for right triangles. So without further ado, this is a visual of what the Pythagorean theorem looks like. And I'm going to go ahead and start with numbers. I'm just going to put some numbers on the sides here. If we are given, ready? If we are given a right triangle and we're given the lengths of two sides. So I'm just going to make some numbers up. 3 and 4. All right, 3, I'm going to say A, I'll use red. We're going to say A is 3. No. A is 4. And B is 3. That's the length of these sides. We know it's a right triangle. We can use the Pythagorean theorem to find the length of the missing side. And the way we do that is we create a square. We know the area of a square is, this is a square, the lengths of the sides are the same, right? So the area of this green square would be 16 units squared, because 4 times 4 is 16. The area of this purple square would be 3 times 3. The area of this square would be 9. These two areas, the Pythagorean theorem says, when we add these two areas together, they equal the area of c squared. 16 plus 9 is 25. Now, how do we determine what c is? C is the side that is across from the right angle, and that's called the hypotenuse. The other two sides are called the legs of the triangle, and they form the right angle. The side across from the right angle is always C, and it's the hypotenuse. So what we can do is, if we know the area of this square is 25, how are we going to figure out the length of one of the sides of the square? Yeah, because 5 times 5 is 25. The square root of 25 is 5. So the length of the sides of this triangle, this side and this side, they're each going to be 5. So C is 5. That's it. That's all we're doing today. And this is what it looks like algebraically. I prefer you to write the c squared first for a reason that I'm going to tell you later on. It's actually, we're going to get to that reason in Unit 7, so it's going to be a bit. But I prefer you, and I think it'll be easier for you to write c squared first. So we're given the lengths of the legs. The lengths of the legs, 3 and 4, always go in for A and B. C is across from the right angle. We don't have that yet, right? So c squared. We don't know what c is, but we know, and A and B are interchangeable. So here's where our 9 and 16 come in. Here's where our 25 comes in. And then we take the square root of c squared and the square root of 25. Now the square root of c squared is actually the absolute value of c, but this is geometry and we're not doing, our lengths are always going to be positive here. Well, length is always positive, but the absolute value, we'll learn about that in Algebra 2. Square root of 25 is 5. So c is 5. So that's what it looks like algebraically. The only way this gets more difficult is sometimes they'll give you C and one of the A or B, and you have to solve for the other A or B. We're going to do an example like that in a little bit. So I want to show you an animation that I found on Geometer Sketchpad, which is right here. Okay, watch. Moving the area for A squared, moving the area for B squared. So amazing. A squared plus B squared equals C squared.